pocket in the sun. So what we want when we're designing our house is we want the sun to come through the windows, particularly in the winter. And we're not too crazy about solar radiation coming through the windows in the winter. So when you have big windows, you can see. It's a trade-off. Sorry? I said winter? I say saying windows. Yeah, we don't.
We want it in winter.
We want it in the winter, we don't want it in the summer. Thank you. So, we want to keep it in the house in the winter.
Let me ask a question. Could you just go over that orientation again? The sun rises in the east and sets in the west. You have the house facing
South.
south.
Yes.
Okay.
May I?
Yeah, sorry.
I built one of these in 1980. South-southeast is better.
Just a little off south is a little better, you're correct. But,
Well, the reason is because about 2 o'clock, it starts getting hot inside the house.
yeah,
The sun is around far enough to the west, but a lot of that light's getting bounced off those windows after 2. And if you don't put any windows on the west side, you don't have to air condition in the summertime, which around here is probably almost as expensive as heating in the winter.
yeah, so you're sort of saving yourself from that nasty 4 o'clock kind of experience. So that's a good point, thank you. Okay. This is the south side of our house. We do have these large windows. Windows galore, because we love the view. And this is illustrating a point. The eaves protect the windows from solar radiation. And so what we want to do is to adjust our eaves so we can use that feature of the design of the house. This is actually the same day, just a little later in the same day. And now you can see the sun it's up a bit high. So this is the key idea, facing south that way. So we have the soffit and the eaves hanging out over the side of the house.
Do you recall how deep your eaves are? About
24 inches.
Oh, okay, only a few feet. Okay,
Only a couple of feet, yes. It's not like they're
But it was
poking
a
out.
great discussion.
I bet.
We agonized over this,
And
I'm-
this is why.
This is the problem that you have. In principle, it makes so much sense. The eaves are going to protect your house in summer from the sun. So here are our windows. So yes, indeed, some of the sun is going to escape the eaves, but we don't want it coming in through the windows, because that's what's going to heat the house up. In winter, on the other hand, what we really want is as much of that radiation to come through the windows as we can possibly get, because that's going to warm up this slab of concrete that we have in here. And the benefit to a slab of concrete, something hard, is it takes in that solar radiation and it stores the heat, and it lets the heat, as I'm going to depict right now, lets the heat kind of dribble out during the night. And then as that heat radiates out and hits the windows, it bounces back, just as I had discussed before. So what we have is a trade-off. The question is, when you're trying to figure out how far out you get those eaves to hang, what do you want to prevent most? You want to prevent summer heat, and if you have these dangling out a long way, that means you get further into the winter before the sun gets in. Okay? Or do you want to maximize winter access, and so you make them shorter? And that's what Kathy was saying. That was the discussion you have. And it's a trade-off. There's no right answer, you just make your own decision.
Now let's go back and point out that the sun angle is different in summer and winter.
Okay, Kathy asked me to point out the sun angle is different in summer than winter. Is that okay? I think that makes sense to most people, but okay. Worth reminding ourselves of that, because that's what makes this worthwhile. Okay, I just want to say one thing. Kathy said you shouldn't include this, but I like this idea. When you drive around, what you see are what I call stupid subdivisions.
yeah.
everybody wants their house to face the road. Makes no sense. None whatsoever. Why don't these people just do that? Not too tough. Now, I know you, if you're living in a sort of terrace house, you can just move each of those row of houses around, but if you're in a situation where you've got a bit of land, you can always make your house orient towards the south. So now I'm passing on to Kathy, who's going to entertain you with a discussion of the design. Okay.
There's a synagogue down in San Luis Obispo in California that is, no HVAC system at all. They totally rely on this technology. But the one thing they use for heat gain with large windows, but with a water-filled water containers at the bottoms of the windows that completely connected in the summer, or in the winter, to the heat gain from the sun. And then in the winter, they would be out of the element, and then at night, release the heat from.
Yeah, and that would be a very good way of doing it as well. Most times people don't use a huge aquarium or something, they use something hard like a concrete floor, which is what we used, which you'll see, or concrete blocks or hard walls that are sucking in that radiation. But yeah, water would do it too.
Yeah, and they were attractive too. It wasn't even.
Yeah, I guess you can get koi in there and get them swimming around, as long as you don't fry them. Then you have fried fish.
Boy,
We'll have them for
Oh, boiled, okay.
Okay, so first of all, can you hear me? Okay.
Yes.
So what we did is took like Ellen said, the sheet from the Earth Advantage and just used that as a guide for what we're talking about. We found that the things we valued and the things we wanted to minimize, we got points for on the Earth Advantage system. If you don't know Earth Advantage and you've heard of LEED, they're both third-party rating systems, so a third party's coming in and saying, is what your builder did or what you did, are they good ideas, do they work? So one of the parts that Alan's already talked about is the orientation and the size. Those were part of the worksheet. Then this part is talking about the building envelope. So the foundations, the walls, skylights, windows. So those are the kinds of things that go into this part. So what we have is a slab. We don't have a foundation, a basement, anything like that. We just have a slab of concrete. Now when we built in Missouri, we had a slab of concrete and they really didn't insulate it. And it was okay. But when we did this one, this is the insulation that went down.
Is that under or over the slab itself?
It's under.
Under.
Okay, so we have this insulation that's down there, and that's like 4 inches thick. And so we get an R15 on our floors. Do I need to go into R value? Anybody? Okay, so that's just a measure of how good it is. So after they put the insulation down, then they put this fine gravel, and then they poured the slab. So I could probably say this 20 times, but it's just amazing how the house works. And we had a fire last night. It was the first fire we'd had in 2 weeks in the wood stove. Okay, the flooring, you don't have cold feet. It's just incredible. So a big part is getting that warm or well insulated on the floor. Go ahead.
is all your plumbing under the slab or
Yeah.
just the wastewater? It's
All
all
of it
under
is.
that?
Yeah, so took a lot of planning. Okay, so these are walls. What they did is 2x6 construction. There's lots of different choices. We've had others. We've done SIPs, structurally insulated panels. We did in Missouri. We like that, but this is tighter. What they did is they had the outside wall on, Then this is a fabric that goes across the wall. And then they blow in the insulation, it's called dense pack. And so you can kind of see the holes here. They punch a hole in it, and that packs it down from the bottom up. And then once that level is done, they go up higher and higher until the whole thing is filled in really, really solid. So that gives us our R28 for our walls. In the attic, again, blown in really, really thick, so we're up to an R60 in the ceilings. I don't know if you have questions or you want to just go on.
So it's standard frame construction basically,
It
with
is.
trusses and...
It is, and we talked to different builders about different ways of doing it, and this, I can't believe you could get any tighter than we are. Now, we're seeing the basic stuff, but there's little things that they did. Corners, so the concrete, you don't get air going, conducting through, things like that. Go ahead.
I look at some of those DIY programs, and they were talking about rock wool for insulation. Have you checked into that?
We looked at different, did I do that?
It's your system.
Just turn it off.
Yeah, it's not your fault.
So you can do this kind of insulation using different fibers. And we were really concerned about what went into the house, the volatile compounds and things like that. We used cellulose. Our builder was Steve Asher Homes, and he said that the amount of nasty chemicals you get in this are no greater than what you would get in, I'm having trouble with the different kinds. So there's cellulose and then there's polystyrene. So we went with this. Now my sister just built in California, and she did use a recycled product that was, I've seen it made out of jeans, reusing old jeans, wool. Those are different options, and we kind of looked at them, but we went with the guidance that Steve offered. Yes?
Yeah, the cellulose is about 50% more efficient on a per inch basis than rock wool. Usually it's got boric acid in it, so it's not fire proof, but it's highly fire resistant.
Okay.
And if you have an old house with a balloon frame construction, you can put this in the walls post facto from the outside.
So with any of them, I think you have to get a non-biased source and say what are the advantages and disadvantages and weigh those. And for us with limited knowledge, having a builder we had confidence in it was the bottom line for us. The roof, now Alan mentioned because of wildfire, we did a metal roof. I think we probably would have done that anyway. We picked up on post-consumer, and as we're doing our points for our Earth Advantage, that gives us extra points. It's Energy Star, and it's, we chose a color that was light, that has more reflection than, say, a dark green would have. And that's based on our concern about climate change and things that are happening. We wanted to be reflecting more. So we're really pleased with the metal roof and what's happened with it. Maintenance is really easy. Another part that brings points with Earth Advantage is having the exterior out of a very durable surface. So we used a stucco, here is in the process, and then the finished product. And there's a gap between the stucco and the wood for air flow, and that's a part of the feature of the, just the whole energy efficiency. I've had friends that have put skylights in and they're really leaky. And so they were very careful in building that all of this shaft is well insulated. The windows, we'll talk about in a minute, are good quality so that we're not getting leakage around this. So we don't feel any cold air in the skylights, and the light is really nice. These are both on the north side, so that brings in some light on that side, which is a little dark.
Do they know?
Air leakage, yeah.
How did you create the airspace between the stucco and the wood?
There's builders here. As I recall, there's a wire, and it's like a chicken wire, and it's spaced out. And so I think that's how the air got in, is in there, and then it goes bottom.
So it prevents the stucco from going through that screen?
Yes, that's my understanding. I'd be glad to be corrected.
So there's a shear backing on the studs, and then there's an airspace between that and the stucco.
Yes.
Do the windows open?
Yes, they do. Now, in Missouri, we had an automatic thing that we just pushed the button and it would open. Here, we have a thing we wind, a crank. In Missouri, we had to worry about thunderstorms in the middle of summer, and we don't really hear, so you open them and you know you're not gonna get a storm coming through and getting water in, so you usually can close them all right. I don't have a slide talking about airflow and summertime, and that's kind of something that came up. We have, so you worry about heating in the winter, cooling in the summer. We have windows down low on the south side, and then we have the skylights, which are up high on the north side. So in summer, as soon as the sun is down, we open the lower windows and the upper windows, and the air just goes right through, and it clears out that hot air. And we sleep fine, and the next morning we close it, and we're cool all day long. So this shows you the low windows on the south side. So that's what we open in the summertime to move the air through.
Is there a screen on it?
Yes, we are screened. Windows, and I have to admit, I'm not really good at this. There's all these numbers about windows, and so I'll only say that you worry about letting sun in, and I'm gonna say it wrong.
You want sun to come through, but you want the light to come through, but not the heat.
I want the light, but not the heat. So, there are different ways they can make the windows, and what Steve ended up doing, because it was critical for us on the south side and north side, he took what we wanted to the window manufacturer, and they said, they talked it through, okay, for this situation, this is what you want. So it was that complicated, and we said, okay, fine, if you think they're right, then we're good with them, and they work really well. But we do have opening ability, not on the big ones, but on all the bottom ones, and then the ones north side as well.
Just a quick question.
Sure.
Would you keep objects and anything that could absorb or, change the wavelength of the sun rays to a heat wave or a longer wavelength? Would you keep that away from windows? Keep objects such as?
You could, we haven't had to worry about
I see.
being that careful. And I think we have one in here of the summer sun, that how much we're getting in. I can say that now because this would illustrate it. In the summertime, we'll get like a foot back of sun into the house. In the wintertime, we'll be way back in here. So it's designed really, really well. That part of it works incredibly well. Okay, doors, you have to worry about air coming in, cold and heat. They're well insulated doors. We did put windows in them. If you're more concerned, then you don't put windows in them. But for what we were doing, it was okay. We could manage to have a window. I think that, okay, so that's the basic shell things. And the next part, we're gonna go on to heating and cooling. And we're about at time to take a break. So I think we'll pause there and take a break. How long do we do?
10 minutes.
10-minute break. Do I need to tell them where restrooms are?
They're right in the middle of the building.
Okay, so just walk down the hall either side, they'll be in the middle. We put a sheet on the back. If you're interested in things we're doing with climate change, and want 2 to 3 emails a month, then sign on that if you're not already on our list. And another thing I'm gonna put back there is the Oregon Climate Declaration, and you can read what it says, it's in big print on the back. But this is basically saying in Oregon, we're concerned about what's happening with our climate and we think something should be done. So it's a real generic, you don't have to be a registered voter or anything.
But this is a sign.
Pardon?
You're asking us to sign it if we'd like to.
If you'd like to, and we'll put these